him. Okay, so yeah, same as Monday. So let's hear whether any of you has any questions or made any progress on their projects, and then we can talk about it. Anyone, anything?
Hi, hello.
Yeah. Hello.
Yeah, I wanted to ask about the testnet, the private testnet. How
Yes.
do you set it up to use Genius Field on it and Atlas? Yeah, not Atlas, not Genius Field. Yeah,
Right. Have you looked at the Atlas documentation?
not
Because
extensively, not
right,
honestly.
because I think there's an example. Let me just share my screen. Um, sorry, just um, right. Okay, you see there. I'm sure there is. Right, here's a chapter on integration tests somewhere. Uh, right. So I think it's explained here. So there is this um, this open source or I mean freely available on GitHub, this WooF pool thing. So he has this Cardano private testnet set up that has nothing to do with Genius Field or Atlas, so but it's very cool. And we basically for Atlas we like slightly modified that or adapted it. And here's basically instructions how to do it. So clone the repository. Right, and just follow the instructions. And right here it says how to do tests. And here's also an example for a test. And I think, if I'm not mistaken, let me just, sorry, just go to GitHub again. Here's also in the Atlas repo, there's a folder with tests. So that's I think the example there. So there is an example, or at least like a harness, a test harness for that. And as I just showed in the documentation, I think there's an example test. So I would just like follow that. And the advantage of using that is, I mean, the parameters are basically up to you. And I think this is, I mean, it's, I don't know exactly, but I mean, on the real testnet, it's like 20 seconds per block. On this one is, I don't know, at least 10 times faster, if not 100 times faster. So it's very fast. So it's not as fast as unit tests, not what Robertino demonstrated when he talked about unit tests or property-based tests, but nevertheless, it's faster than doing something on the real testnet. But the nice thing is also that in principle, you could also do it on a real testnet. I mean, then it's much slower, but I mean, because it's it's a real Cardano blockchain. I mean, the parameters are different, but in principle, it's a real blockchain. So in principle, the tests that you write for the private testnet, you could also execute them on the real testnet if you want. I think we have never done that, but in principle one could, because it's just another Cardano blockchain. And it runs, I mean, locally on your computer. I think it sets up 3 nodes or something. So it runs 3 nodes on your local machine, and it's like proper Cardano nodes, but the parameters are different. So therefore, it, for example, runs faster, and you have control over the money. So, I mean, in the beginning, there's, I don't know, let's say 100 million ADA or something, and then you can basically you have the master key, so you can set up who has how much in the beginning. But I think that's all explained here. And yeah, it's quite cool. So it's like, I mean, ideally you would start with unit test, property-based test, then do this private testnet thing, and then test on the like a real testnet, and then go to mainnet. Does that answer the question?
Oh yeah. I think the documentation is quite helpful. It has everything, like I said. So yeah,
Yeah, I
I
think
think
so.
yeah.
And I mean,
Yeah.
at Genius Yield, we're also using that in our continuous integration. So each time there's a push on main, basically, I mean, before, or I mean, we don't allow pushes on main, but if there's a pull request on main, then this is always run. So we use that all the time. So it should be up to date and working.
Oh, so it's a complete mirror of Cardano, like the mainnet. Okay. Cool.
Yeah, I mean, the only difference is the parameters, that slots are faster and so on. But apart from that, I think it uses like realistic parameters and so on. And it's just, I mean, it's a normal Cardano node that runs. I mean, a proper Cardano node. So it's no simulation or anything. It's a proper blockchain. Just that all the nodes live on your own computer and don't go on the internet.
Oh yeah. That's cool. I think it
Nice.
helps make testing really fast.
Yes.
So,
And because it's a proper blockchain, I mean, you can use everything that you could use. I mean, you can use Cardano CLI or Atlas or Lucid. I mean, anything to talk to it basically. So
nice.
yeah.
Yeah, I think I'll play around with it. Yeah.
Okay.
Thank you.
Welcome. Are there other questions?
Maybe I can ask.
Yes.
Okay. I think there's a question from Tony first before I progress.
Yes, just now,
Okay.
Tony. Tony, go ahead. Maybe you can speak if you want. But okay, the question is, how does the proof of stake protocol works in Cardano?
Right. Good question. So, what can I say? I mean, so there's a nice story how it works, and then there's how it actually works. Let me see whether that I can still. I mean, the nice story is that in principle you do something called follow this. I mean, we have time, so I mean, as you know, on Cardano, I mean, the currency is called ADA, but 1 ADA is 1 million Loveless. So the smallest unit is called Loveless. But I mean, on Bitcoin, basically we have a similar setup um, with Bitcoin and Satoshi. So I think it's also 1 million. So 1 Bitcoin is like 1 million Satoshi. Could also be more. It doesn't matter. But anyway, the smallest unit there is called Satoshi. So this algorithm is called follow the Satoshi. I mean, it should be called follow the Loveless. But it's not how it's implemented. But that's basically the idea how proof of stake works. So the idea is, I mean, every single coin on the blockchain, I mean, Loveless in our case, I mean, it's like separate coins because of the UTXO model. You have like more or less like separate coins. So there are whatever. I mean, it's like every epoch certain number of loveless from the releases from the reserve is released, but I mean at any given time you have like a well-defined total number of loveless, and what you can imagine how it works is that basically there's a lottery every slot actually, and one of these coins is randomly selected, and then the owner of that coin, in whose wallet it is, basically he has the right to create the next block. And then of course, I mean, obviously the more loveless you have, the more money you have, the higher your chances to win that lottery. So that's the rough idea. But and actually it's not, I mean, it's not about so first of all, it's not about how much you have in your wallet, it's how much, I mean, basically these stake pools. I mean, the Cardano nodes are so-called stake pools, and it's about how much ADA is delegated to a stake pool. So basically, you don't look into which wallet the winning loveless is, but you look to which stake pool the winning loveless has been delegated, and that stake pool then has the right to create the next node. So that's one thing. And but I mean, that's like in theory the general idea, but in practice it works differently, because if you had that, then I mean, I think the first version of Cardano, like the original Ouroboros paper, was sort of like that. But the problem there is you need this global lottery, and in order to make that work, like in a trustless environment, you need a lot of communication. So there was like very complicated protocol how like the stake pools had to coordinate with each other and send messages in order to amongst them basically do this lottery thing. And so the actual version of Cardano or Ouroboros that's used now, Praos and Genesis, so the newer versions, they do it differently. So there, basically, the idea is everybody does a private lottery. So every stake pool runs a lottery by himself. So like they're like lotteries in parallel, but the lotteries are done in a way that, first of all, the people can't cheat. And secondly, the chances of winning are again proportional to how much stake they have. So if you have twice as much ADA delegated to your stake pool, your chances of winning your private lottery are twice as high. And you, as I said, you can't cheat. So there's something called VRF, verifiable random functions, that's used for that to do these things. But because it's these private lotteries, that also means that because they're completely independent of each other. So basically every stake pool operator every second flips a coin, and the chances of winning that are proportional to how much stake he has. But that also means, because they are independent, these lotteries, that several, I mean, in principle, there can be no winner, or there can be like more than one winner. And the parameters are calibrated in a way that on average, only every 20th slot, there will be a winner. That's where these 20 seconds come from, that the block is on average every 20 seconds. So that means, like, on average, there is no winner in these parallel lotteries, and every 20 seconds on average, at least one stake pool wins. But it can also be more than one. So on Cardano, it can happen that several stake pools win this lottery and can create block in parallel. And then consensus sort of sorts out, I mean, it's indeterministic, but I mean, one of those blocks will eventually end up on the blockchain, and the other is like a mini fork that will immediately be discarded, or I mean, soon be discarded. So yeah, so that can happen on Cardano, that in one slot there's more than one block, but then because of how consensus works, after a minute or a couple of seconds, basically the blockchain decides for one of those two, and the other one is ignored. Yeah, so that's how it works. Does that answer that? I mean, I can also go. Okay, no.
Yes, thanks.
I mean, I could also add, I mean, this whole staking thing. So there's this delegate, I mean, on Bitcoin with proof of work. I mean, in principle, I mean, first of all, I mean, every node is on its own. I mean, it's about I mean, the more hashing power you have, the higher your chances of winning. And then, of course, people do pool their resources. I mean, you get these mining pools, these Bitcoin mining pools, where several people that just like want to do Bitcoin mining, they basically work together, and then, I mean, they each have their computer or their server farms or whatever. But then if one of them wins, they basically split the winnings in this pool, which, I mean, makes it easier to, I mean, leads to a more steady income. If I mean, if you mine Bitcoin on your own, then maybe only once every 2 years or so you make a block. But then if you make one, you get whatever, $30,000 or so. But I mean, it's very unpredictable income, because I mean, chances are very low that you make a block, but if you make one, then you get a lot of money. And with these pools, by sharing, you get the volatility lower. So I mean, because then chances are higher that one member of your pool will get a block. I mean, then every member of the group gets less, but it's more steady. But I mean, the point is, on Bitcoin, this is like a social thing, off-chain thing. So that's not part of the protocol, of the Bitcoin protocol. I mean, people do that off-chain, that they organize in these pools. And on Cardano, it's different. I mean, there, the stake pool concept is built into the protocol itself. So whenever you have ADA, I mean, when you set up a wallet, you create your keys so that you can spend your money, but you also can create the so-called staking key, which gives you the right to delegate to a stake pool. And so I mean, you can run your own stake pool with your own money if you want, but you can also delegate to a stake pool. And that's, I mean, that's something that's built into the Cardano protocol itself. And when you do that, then you add basically your voting rights or your winning rights, your lottery tickets, to that stake pool. You can still, I mean, and it's not like staking on Ethereum or so, that while you are staking, you lose custody of your money. So you still have the money in your wallet and you can spend it. But I mean, while you have it, it basically contributes to the stake pool and increases the chances of that stake pool to win this lottery. And then it's also built into the protocol that if, I mean, every 5 days, so in Cardano, you don't, I mean, these block rewards are not paid for every block, but only every 5 days, so-called epoch. And basically, the protocol looks how many blocks you create. I mean, the stake pool created in these 5 days, and then calculates how much money you get for that. And then automatically, people that delegated to that stake pool get paid. I mean, a share of that money. So that's all built in. So you don't need to have like external agreements, how to split the rewards and so on. That's all part of the ledger, the Cardano ledger, automatically. So that's built in at the very basic level already, this pool idea. And it's also set up in a way that I mean, how much a pool gets for creating a block, it's not proportional. So it's not, so it's somehow calibrated in a way that pools don't become too big, because that's also a big problem on Bitcoin, that even though Bitcoin claims to be very decentralized, in effect, they are not, because of these mining pools. Some of the mining pools are so big that they have almost 50% of the total power in Bitcoin. So these mining pools, I mean, they are only like the first, I don't know, the top 5 mining pools control, I don't know, 80% of hashing power or something. So it's actually very centralized in that sense, Bitcoin. And on Cardano, we wanted to avoid that. So the reward system Cardano uses somehow makes sure that if a stake pool becomes too big, attracts too much stake, then he doesn't get any more rewards. So the rewards are not proportional to the size of the stake pool. They somehow are sort of capped at a certain amount. And that leads to this effect that on Cardano, we have like 2,000 stake pools, 1,000 to 2,000 stake pools, but not more, and they are all roughly equal size. So the power is not concentrated in a few, but spread evenly, more or less evenly, over more than 1,000 stake pools, which makes it much more decentralized. So I hope that answers that. Other questions? Anderson, you had a question, you said?
Yeah, for me, it was suggestion of a project. How someone approach in building a project similar to the Medium site? So whereby you have like a contribution to particular articles, but then you can have a subscription model whereby for one to be able to access a certain article, the subscriber needs to pay some sort of ADA to be able to view a particular author's article. How can one approach such a project?
Right, let me think about that. Hi, Robertino, you are back.
Hi everyone. I think one of the I'm jumping in like right off the bat, if that's okay.
Of course, I was hoping for that.
I think right off the bat, the only real issue on implementing that schema will be the recurring payment side of things, because blockchains don't do anything by themselves, so you need an external way of making the charging every month. So that I imagine that could be either asking for a signed transaction every month, first of the month from the user, or maybe every time the user enters, you check if that user paid for that month, and then you ask for it, because you have, if it's connected with the wallet, you have access to the wallet, so you can check if the user already paid for that month. Else, I'm imagining you could have some sort of prepayment wallet where the user can put X amount of money, and you just in a smart contract, and you just charge every month what you are owed, and then the user at any point in time can retrieve that money back. And I'm thinking those are the first two that comes to mind to solve the recurring side of things. The rest is, I think, is not super hard to figure out. You just need to check in the front end. You just need to get the address wallet, and when you go to the backend to request the block, you check. I mean, of course, you don't need to query the blockchain live, because you already have an SQL database or some sort of database with all the keys and if they made the payment that month. So you just need to check if that address is inside that set of keys of addresses, and if it is, you give it access, and you from the backend you send the article to the front end. Else you prompt for the payment.
I am wondering how to do this. I mean, it's always a bit tricky if you want to link a real world resource to something blockchainy. So in this case, the access to a certain article has to be, I mean, that's like a real world thing or an off blockchain thing, has to be linked to some information on the blockchain. I think if what you describe, I mean, it's very centralized, right? So there's this server where all the article or the blog posts are, and then the server basically checks on the blockchain whether you paid your subscription.
Yes.
I mean, I don't know whether I think it depends on the requirements if that's acceptable, or whether it must be somewhat more central, more decentralized. Anderson, so that depends. I mean, yeah, I mean, as Robertino points out, I mean, there are like two aspects: this payment model itself, how to, I mean, to basically do recurring payments and register subscriptions and so on, and then how to actually link the subscription to the right to do something, or to watch articles. I mean, in principle, yeah.
So the thing is, so the writers need to trust the company that they are going to be paid proportional to what they wrote, something like that, because the user doesn't really care, But yes, like if it's like a medium like company like service, they pay the writers by the amount of views. But yeah, I'm not sure how to decentralize that part, because the person that serves the front end has either way the power. I'm
Right.
how to take the power back, because I'm guessing, like, if you're being like super you don't care about fees, for example, I'm guessing the front end could create, I mean, you know what, maybe that's a good function for Hydra. You can open a Hydra head, and each time one user reads an article, you like kind of accumulate all the all the articles the person read. At the end of the month, you close the head and you output an UTXO with the history of everything the person read. So then you can use that to consume the writer can use that on-chain datum UTXO to consume his money, the money that he's owed from the company's contract. Does that make sense?
I think it does. I'm just wondering, isn't that a privacy nightmare? I mean, probably, I mean, you don't want the whole world to know what you read, maybe?
Yes, you're right. But maybe could you anonymize the connection with the, maybe, I mean, you could potentially just be in a key. Like
Yes.
no one needs to know that it's you. You could, like, every
Right.
time you open the Hydra head, you could like use a new key, right?
Mhm. True, yes. Yes.
But I'm thinking, you also in that model, you also need to trust. Now, I mean, the writer needs to trust the user and the company now, because they do everything in their own Hydra head. So I'm not sure how could the writer be part of that, because every entity needs to sign every transaction, so it's not feasible for the writer to be like 57 different, like 100 different Hydra heads signing everything. I'm not sure how to solve that part.
Unfortunately, I'm not very good in cryptography. I was just wondering, I mean, to make this sense, I mean, whether there's a way to, I mean, basically encrypt it. I mean, like you send somebody the encrypted blog post, so he already has it. And I mean, when he pays, he basically gets the key, but the key is only valid for him. I mean, so that he can be, I mean, that basically the smart contract guarantees the moment. I mean, that would be nice if there was, like, you could be sure if I pay or if I have this. Yeah, I don't know. I'm probably talking nonsense. I mean, would be nice if one could somehow make that deterministic, that you don't have to trust anyone, that you know if something happens on the blockchain, if you have a certain something signed, then you can decrypt something that, I mean, then you can read something, but I'm not sure whether that's possible.
I mean, I think if maybe you don't need to be part to just read what the heads are doing, because I mean, I'm not sure, because that's maybe the medium, pseudo medium company can have all the Hydra heads open for people to inspect. So then in that case, the writer could, he or she doesn't have the power to do anything at the particular time that the readers are reading, but has access to the history of everything that is happened through the head. So it knows that it should get paid 100 data. And by the time all the heads close, he should get that UTXO saying he should charge 100 data, for example. And that wouldn't be trustless, but it would be transparent at least.
But Anderson, what are the requirements basically? I mean, what's the important part for you? That you somehow have like a subscription on the blockchain, or that this like that the access to the documents is somehow trustless or decentralized?
My thinking was if an author contributes his article to that particular resource, medium-like resource,
Yes.
then the author gets to be paid directly for every read time a particular subscriber reads that particular article. So I think the challenge is regards to how can we maintain that subscription for maybe a certain month. Because the simplest method would be anytime you want to read that article, you have to make a transaction in order to be able to access that article.
Mm-hmm.
So
Right.
I see that. I think that's the challenging part, is maintaining that subscription process.
I mean, if you need to pay for everything you read, it's going to be super expensive. So
Yes.
that's why I brought into the conversation Hydroheads. But I'm thinking, if you implement a higher head client that could be run by the writer and automatically signed every transaction with his own key, I think that will solve the issue of making sure that the writer gets paid the fair amount, or at least that it's recorded the amount that it should get paid, and then like you solve the making sure with a smart contract that consumes the UTXO at the end.
Mm-hmm.
But I mean, the value provided by these platforms is not the content for the writer. I mean, it's not for the writers, it's not the content, because the content is worthless if no one reads it. So the value provided by the platforms is the distribution. So I think the writers are fine by giving the content to the company, as long as the company provides the value back of distributing it. If the company just has the content without distribution, the writer doesn't lose anything, really. Does that make sense? So like,
makes a bit of sense. So
yes, sorry.
Just mention. So the company has to run their own Hydra node, if I've gotten that correct.
For that, I'm thinking for the solution that I have in mind, super rough solution that needs to be thoroughly polished. And I think that both the company, the reader, and the writer needs to be part of the head, of a head that regards the article that the reader wants to read. So in that regard, the user needs to, the company itself needs to implement 3 clients and a server. So the client is like the app, the Medium app that the client uses, or the front end that opens the that interacts with a server that they run. And also the writer needs to have in its own infrastructure, his own service running Hydra heads. So he's in charge of his own keys. Does that make sense?
Yeah, I think it makes sense. Makes sense.
I was just thinking, I mean, sorry, how you can do it basically that you give access to something in exchange for money automatically and or like trustless. And I was just wondering, I mean the author, I mean, let's say Robert, I write something and you want to read it, but I want money for your right to read it. I mean, I could encrypt. I mean, this is now just peer-to-peer between the two of us, basically, independent of like a company that like a platform. I mean, I could encrypt the document and send the encrypted document to you. So you have the document, but you can't read it because it's encrypted. And then you could pay me by putting, I mean, not sending me money directly, because I mean, if you do, then maybe I don't give you the key. But you put it in a smart contract, and the smart contract only unlocks if I provide the key, basically. So I unlock it with the key. So the moment, I mean, in order for me to get the payment out, I have to basically in the redeemer give the key, and then once I do that, then the key is on the blockchain, and you can use it to decrypt the document. I'm not sure whether that's useful, but something like that I think one could do if one wanted to. This is actually used for these bridges, or for one way to transfer, or that's one way to transfer assets from one blockchain to another, to use something similar. But anyway, I'm not sure whether that's relevant in this context.
Yeah. I mean, yeah. I mean, like a time lock with the. But I think, yes, it would work. But in this case, as soon as the first person unlocks it, that's game over. Like,
Right. That's why I think in this case I would encrypt it twice. So I would first, I mean, you have like a public key. I know your public key, so I can first encrypt the document with your public key. That means, I mean, these private public key things, I mean, I don't know, it depends on the algorithm I think you use. But RSA, for example, this famous one, or the most common one, one of the most common ones. I mean, normally, right. I mean, the way it works is, I mean, independent of the subscription thing. I mean, the way it works is normally this public key cryptography. If I want to send you a secret message and I know your public key, then I encrypt the message with your public key, and only you can decrypt it because you have the private key. So I could, I mean, if I now have this blog post, I could encrypt it with your public key, but then encrypt it again with this, with a secret key, basically, that you don't know. And that is the one that I reveal when you pay me. And then you basically, after the reveal, you can decrypt once and then use your secret key to decrypt it and read it. But other people can't do anything with the key, because when they apply it, they still have it once encrypted with your private key. So that, I mean, because you said it's game over once the key is out in the open, but you could prevent that by encrypting it twice. I mean, with your private key and then with this one.
yes, that would work as long as the receiver is not malicious and reshares it once decrypted with everyone. So
Oh, you mean the document? Yeah, sure.
Yeah,
But I
yeah, but
think that you, I think that you can't prevent anyway, can you? I mean, also not with Medium. I mean, I could.
could you time lock a collateral? And if you share it with, I mean, that you locked some sort of collateral for a month, So at least you're secure for a month.
Yes, I suppose. But I mean, this is, I think, a general problem. I mean, if I have a subscription for the New York Times, for example, I mean, in principle, I could, once I read it, I could like copy it and put it
Yeah.
publicly on the internet, right? So I think that you
Yeah,
can't prevent that.
And people usually don't. I mean, you have these blockers, but usually you don't get like a website that reshares whatever the New York Times has. So it's made
Right,
at scale at least.
exactly. You normally don't.
Yeah. Maybe that's not a problem then.
But
So,
yeah, sorry.
so yeah, Anderson, you could combine what Lars says with what I said, and you have the perfect the perfect platforms where you don't have to trust anyone.
Yeah. But
I mean, of
thank
course,
you.
it could it could still be. I mean, I could just have garbage in my block. I mean, maybe when you decrypt it, it's just garbage. But I think that's something you can't really prevent.
No, I mean you could have. Oh man, this is getting complicated. But but you could have some sort of trust system like a 5-star rating or something like that on chain.
Yes, yes. And I mean, unfortunately, I mean, I should really learn some more cryptography because they are fascinating things. I suppose there are like with zero knowledge proof and stuff, you could do things like that you can basically say, I mean, that like before you pay somehow, I don't know, like a random section of the thing is decrypted, so you can basically make sure that, I mean, you can like get a sample. You can pick where, and I must send you. If it's 10 pages, you can pick a number from 1 to 10, and then I have to show you that page or something like that. I think they are quite sophisticated, like protocols that, but yeah, that's probably getting too far for something like this.
But couldn't that be made with simple merklerization with you share a node and the rest of the tree, and the node itself is the sample, and then you can hash it and check that it's part of the tree?
That's right. Yeah, something like that you could do.
That would be cool.
Yes. Yeah, so yeah.
You just need VC funding to build on that. Tony?
Tony, go ahead.
Okay, hello, can you hear me?
Yes.
Okay, very
We
good.
have
So,
to.
okay, so I want to get okay, I didn't have a microphone, but anyway, I just wanted to give some of the progress updates, what I'm planning to work on. So I'm still trying to, I mean, kind of, okay, I feel like I've not really understood this whole idea of smart contracts and to the extent that I can actually do, you could say, a meaningful project. Because anyway, but I've settled on just working on an idea of a stable coin. So that is which is what I think Robertino and demoed the last lectures. But I'm still trying to wrap my head around, I mean, how they really work, especially.
Tony, I think I'm not sure if
especially because I think both actually maintains value despite any fluctuations. Yeah, I also have another course we can start there. Last the next one. So just to really understand exactly how exactly the value maintained by putting by over collateralization of a given unit of a stablecoin. Yeah.
Yeah, very good question. I think because I think Robertino's I may be wrong, but I think Robertino's example was actually incomplete, missing one ingredient. And I mean, I'm not sure, Robertino, you didn't have time to confirm that, but maybe that.
I will look for the while you explain. I mean, maybe I will look for the graphs first and go over it, and you want to like say what you wanted to say first, and then we like discuss it.
Yes, maybe. But first of all, I should probably open the whiteboard. If I can, right. I just start one again. Okay. Can you see the whiteboard?
Yes.
Although, yeah, I'm not sure whether whiteboard is good or whether I should share a document. Yeah, but I think that's fine. Right. So the way I understand it, so you want to mint a stablecoin, you want to use this over collateralization. So I forgot what everything was called. So there, I mean, there was a minting policy, and there was there only no, there was a minting policy, and oh yeah, and this what was this contract called where people place the collateral, Robertino?
Collateral validation,
Collateral.
minting policy, and the oracle.
Oh yeah, right. So the Oracle, I mean, that is like a different, I mean, this is like a tricky problem. So we assume we have this Oracle. So that has like the price. So let's say you want a US dollar stablecoin, and Robertino called it USDK. And so the Oracle has the exchange rate from ADA to US dollar, let's say. And let's say at the moment it's 1-to-1. Okay. So that's one thing. And I mean, this is like out of scope how to do this. How to implement that. So you need some either, I mean, for example, a trusted source that somebody, whatever the US government or some or the Coinbase or somebody basically publishes this. So we assume that the exchange rate is available. And now you want to mint a coin that is, I mean, a USDK token on Cardano that's stable in the sense that it's always worth $1. I mean, that's the challenge. And the idea, I mean, what Robertino presented was that in order to mint this stablecoin, somebody has to over what did you use? 150%? No, 300%, or what was it?
150 minimum.
Okay, 150. So over collateralization. So somebody wants like to mint 1,000 USDK. So and he must over collateralize by 150%. So that means he must basically put down collateral worth 1,500 US dollar. And given the current exchange rate of one ADA is $1, he must put down
150 ADA.
1,500 ADA, right?
Oh, right. Yeah.
So there would be this transaction that would use the Oracle as a reference input.
Yes.
And he would have so he would have use a UTXO of, I mean, as input 1,500 ADA. And then this thing would have two outputs. Let me just draw the boxes first. So this would be in the collateral contract. And that would be him. Hang on. Just drawing boxes, and now I write stuff.
We can also like use these shapes if you want. We have
right. And so let's say this is me. So Lars, I want to mint. So I start with 1,500 ADA. Then I create this transaction. This is TX1, my first transaction. Why the T disappeared. And right, so this, yeah, Tino makes it nice. So this is now the collateral, yeah. And there would now be the 1,500 ADA. Does it have to know? Yeah, that's right. Value 1,500. And I would get 1,000 USDK. So this is this USDK token. So the minting. So in this transaction, the minting policy of this USDK would check that. I mean, because I mint 1,000 USDK, that at the same time in the minting transaction, the correct collateral is paid into this collateral validator. So I can only mint these 1,000 USDK if I put like 150% of the value, which given the current exchange rate is 1,500 ADA. So here one should say it's 1,500 ADA, or yeah, that's ADA. Right.
The user and minted SDK are the values recorded at the datum.
Yes. Okay. So far, so good. So now I have these USDK. And now your question is, I mean, what makes it stable? And I think there was something missing from Robertino's thing last time. Because, I mean, he explained this. I mean, one thing that I can do is I can, if I basically pay back the 1,000 USDK, if I burn them again, then I can get my collateral back, right? That's one thing.
Yes.
Okay, and then there is this, what's it called, slashing? I forgot if it's under collateralized.
Yes. So maybe before I can explain like the mechanism how initially was explained, and you can pinpoint where the flaw you found.
Yes. Okay.
The limitation. Sure. So at this point, these 1,000 USDKs have a value that is proportional to the actual USD dollar using this oracle and this collateral indirectly, but the value fluctuates. So that's the thing. Like we have to figure out the mechanism to make sure that when the value of with the ratio, the value of ADA per USD per ADA goes up, we have to incentivize that the ratio has to go down again, like the value of the minted USDK has to go down to maintain the 1-to-1. And when when the value of ADA goes down, we have to incentivize that we have to have some sort of way for it to go up. Those are the two like requirements for it to be stable, right? So if the value of ADA goes down, if the value of ADA goes up, I think that's the easiest. Let's see, can we make, maybe I'm going to go up. If the value of ADA goes up, then this is not what I wanted to do. This. Then the user can mint more with the same amount of collateral. Right? So that's the thing. In theory, that's the only thing we need. So because the user is allowed, we are going to discuss like the technicalities of how does it, but if like the idea is just this, if they use now that because the value of ADA is more valuable in respect to the dollar, the user can use with the same amount of collateral mean the amount of value meant more USDK. So in the exact implementation that we used, the user needs to consume everything and regenerate. And by doing that, the amount of mint USDK at the end of those two transactions, or like a single super transaction, is the same.
I mean, if to be concrete, if one ADA was worth now $2, then with the same collateral, 1,500 ADA, I could now mint 2,000 USDK.
Exactly. So you will need, with the actual implementation we have, that's an implementation issue that can be changed if you want. But with the current one, you have to consume the previous collateral and in a separate transaction re-mint your coins, and you will have more. So because now there's more USDK in circulation, like the value, like at the end of those two transactions stays the same. You are incentivized to do this because there's value for you to grab for free, basically. If you don't, you are just like having value sitting around. So you have the incentive of doing this to get more stable coins to do whatever you want to do with them, right? That's how you keep the value from going too high. And the other case is when the value of ADA goes down. That is a bit more complex. So in the case of the value of ADA going down, we have this threshold that is, in this case, the threshold we chose is 150%, but that's not relevant. I mean, you can change the threshold to anything over 100%. So what we are going to do is we are going to allow anyone that is anyone that has stablecoin to liquidate someone else's position. In this case, Lars has a position. If their collateral is under this threshold. So imagine I'm looking at the blockchain, the value of ADA goes down. So I say, hey, Lars is now, the value locked by the Lars collateral is less than the percentage. So now I'm incentivized to do the same transaction Lars did. Let's move it. I'm incentivized to do the same transaction Lars did, but with more ADA, because now the Oracle, in this case, for example, 2 ADAs is 1 USD. So now I could put 3,000, but I choose to put 4 because I want to have some margin of error. And doing the same transaction 2, I mean, the same type of transaction, but if a different one after Lars, I create this validator that I'm the user, Robertino. I lock 4,000 ADA and I mint 1,000 because I'm just cautious about it. So
Yeah.
yes, Robertino gets 1,000 USDK. So now I created a new collateral with the correct ratio between USD and ADA, right? And I can use this to liquidate this, this 1,000 USDK to liquidate Lars' position. So this is a new transaction that it's a bit. So I take Lars Lars collateral. I need as well the current value in the Oracle. And I also take my USDK and I create a transaction 3, that liquidates Lars's position with and after that I get Lars collateral, which was 150 ADA, and that's it. So by liquidating Lars, but as soon as the value, once Lars minted, as soon as this ratio change, now the value of the stablecoin is wrong. The coin is not longer pegged to the US dollar. But because I have the incentive that I'm going to sacrifice I'm going to sacrifice 100% of the value to get 150% the value that Lars left behind as collateral. I have the incentive to create a collateral with the correct ratio to then take part. Actually, this is the whole thing, but I could mint 150 to make it 1500, and Robertino at the end of the whole transaction at the end of the transaction there's 500 USDKs in circulation, but with the correct ratio between USD and ADA, so they are actually like still pegged to the US dollar. But Lars found something.
Yes, I think, I mean, I think there's one crucial operation missing that you can do on a collateral. I mean, the way you explained it, you can do two things. I mean, the one that set it up. So in my example, me here and with this collateral, I can just burn the 1000 USDK again and get my collateral back. So I can get the 1500 ADA back. That's the one operation. And the second operation is if the collateralization in a collateral drops below one. I mean, it's exactly 150. So if ADA drops just a little bit in price in comparison to the US dollar, then this is too little. It's less than 150%. And then somebody else like Robertino can just grab my collateral. So that's the two things you explained. And I think the important operation is missing, a third operation, that anybody can burn USDK and in exchange get like the current value according to the Oracle in ADA from that. So for example, we can do that proportional. We can also, to keep it simple, that it must be the full amount. So like in this case, there were like 1000 USDK. So if somebody burns 1000 USDK, he can get out of this collateral the corresponding value. So at the moment here, the exchange rate was 1 ADA, 1 US dollar. So if somebody burns 1000 USDK, he gets 1000 ADA out of this collateral. And the rest, the 500, would go back to me. because that is exact. I mean, that's the whole point, in my opinion. That's like the most important operation. I mean, what does that mean, stablecoin? It means, I mean, I'm supposed to be able to exchange my one USDK for $1. Now, obviously, on the blockchain we don't have US dollar, so I must be able to exchange it for ADA. I mean, that's the point. Why would I mean, if Robertino pays me in USDK, why would I accept that payment? Well, I must believe that I can somehow turn that one USDK into $1. So how do I do that? Well, I first exchange it into ADA and then exchange the ADA into US dollar. So I must get like the right amount of ADA. So at the moment, I would be happy. I mean, if somebody gives me USDK, if I know I can exchange one USDK for one ADA, because then I can exchange it one ADA for $1 and I'm fine. So that's, I think, why we need this. And if now, for example, the price of ADA goes up, then for my USDK, I would get less ADA out of this collateral, but that's still fine because I mean, ADA is now more valuable, so I still get $1. And the point of this whole over collateralization thing is that it also works the other way around. If the price of ADA drops a bit, then there is enough, because of the 150%, there's enough stored in this collateral to still get me $1 worth of collateral out of it. So I think that is like the main point, or one of the points. I mean, how this over collateralization works. It guarantees that basically the USDK are backed with sufficiently many ADA.
And if yes, I see what you mean. I thought about solving this like by bootstrapping, but I think it's easier to just allow for modify the burn case to allow anyone to burn as long as they pay the extra 50% to the rightful owner. And I think
Yes.
that's it. I mean, that will be it.
Yeah, I think this is somehow the point. I mean, for me, I mean, there are these other stable coins. I don't know what they are called, like fiat-backed stable coins. I mean, there I think it's very. I mean, there the idea is, and I actually to this day wonder why nobody actually does it like that. I mean, I mean, first time I understood how a stable coin can possibly work. I mean, it's in principle very simple. I mean, with real world. I mean, let's say I want to mint I mean, let's call it euro, okay, Kenyan euro. So the way it works is, I mean, you come to me, you give me 100 euro, like fiat money. I put it in a safe, and I mint 100 euro K. And then you can do whatever you like. But everybody that gives me 100 euro K, I go to the safe. I mean, burn the euro K and give him the note, the bank note that you gave me, the euro. I mean, that way it's guaranteed it's stable, because it corresponds to physical money in exactly the same ratio. And I don't know why nobody does it like that. I mean, there are, of course, like US dollar tether and those things, but they don't do it like that. I mean, they don't put it in a safe, they invest it. And then they sometimes lose, and then the stablecoin crashes. But anyway, I mean, that's the idea. So that, I mean, you trust the value of the stablecoin because you are guaranteed that you get like the equivalent amount of it, whatever it's pegged to, in exchange for your stablecoin. So if you now don't do it with a safe and real money, if instead you do it on a blockchain, I mean, there are no US dollar on the blockchain. There's, for example, ADA. So the same idea. Somebody gives, I mean, you give me ADA, I in turn give you the stable coin. But then, of course, the problem is that ADA, I mean, it fluctuates in comparison to the US dollar. So therefore, this over collateralization. So you give me like 150 US dollar in ADA, and I give you 100 US dollar. And now if ADA fluctuates against the US dollar, but not too much, I mean, if it loses in value, there's still enough ADA in the collateral to give you like the correct amount back. That's the point. And these slashing and taking other people's collateral, that's just to incentivize. So if in my case, I mean, if I want to mint this stable coin, I put down collateral, and if now the price of ADA drops and it gets close to this 150%, then I must basically top it up. I must put down more collateral so that at any given time it's guaranteed that if somebody wants to cash in his USDK, he gets the correct amount of ADA. So that basically just incentive. I mean, this danger that somebody else can steal my collateral if the over collateralization is not maintained, just incentivize me to always have enough ADA in there, so that people at any time can cash in their stablecoins. And yeah, that's basically the idea. That because I mean, you don't put money in a safe. Instead, you use ADA as collateral, but the price of ADA can fluctuate, so you must put more ADA. And then, of course, there's still a little risk that it drops so quickly that before people can do this, it's already. I mean, but I mean, if, as you said, Robertino, in reality, it's like 500% or something. So it's quite, or it's very unlikely that ever happens, that ADA would drop so fast that it's too fast for people to get their money out, basically.
Yeah, I'm not sure if I told that in the stablecoin. I think I did.
I think you did.
Okay, perfect. So yeah, as long as the value is on over 100%, we're good. Tony has a question. Yes, Tony.
Yeah. So maybe like a follow up. Okay, I felt like the explanations were a bit too fast. I still don't have a good intuitive understanding of, I mean, for example, if you could just zoom in into a scenario where the value of, let's say, ADA goes up in respect to a US dollar. From what Lars was explaining, I understood that it's as if you, I mean, you would expect that you'd get an equivalent amount of ADA, which is proportional to the, let's say, 150% ratio. But it seems you only get an equal amount of USD. I mean, basically, if you could just zoom into that case and just look at what happens exactly.
I think, can I do a document again? I think that's easier than,
Sure.
or not.
Yeah. I was about to like draw the transactions in this value goes up data, but if we can do a document. Are you signed in to Zoom, Tony, just in case like we're going to close this? So you, or maybe Anderson, if you can save these graphs for later to share them.
Yeah, I've saved it.
Okay, perfect. Yes, let's do a document.
Okay, thank you. Right. Let me share. Let's see. So we need a table. What do we need? We need the oracle, the collateral, and then let's say 2 people or something, and lots of rows. So oracle, Lars, Latino, collateral. Okay, so let's say 1 ADA is $1 US, says the oracle. And let's say I start with, I don't know, 1,000 ADA. Robertino starts with 1,000 ADA. Okay, so now Robertino wants to mint this stablecoin. So let's say he puts, let's say he wants to mint 100 USDK. And let's say we keep this over collateralization by 150%. So he would need to put at least 150 US dollar down as collateral, but he wants to be careful. So he puts 200 US dollar down, which at the moment corresponds to 200 ADA. So he puts 200 ADA into the collateral. And for that, he gets, so now he has 800 ADA and 100 USDK, let's say.
Can you add another column to the left to say what happened at each row?
Yes, that's a good idea.
Okay.
Robertino mints 100 USDK. Okay.
Yeah. Perfect.
So now let's say whatever Robertino hires Lars and pays 50 USDK. Doesn't matter. So now I have 1000 ADA and 50 USDK.
I need a
Robertino has 100 ADA and 50 USDK.
plus
Okay.
new math knowledge.
Yes, I mean for some service, you pay me in USDK to write your Marlow workshop presentation for you or whatever. You wouldn't get that for 50 USDK, but anyway. So okay, now I want to buy whatever. I want to go for dinner in a restaurant, and they of course don't accept crypto. Okay, fine. And now let's to make it more interesting. Let's say now one ADA is drops. So ADA drops. So let's say one ADA is now only 0.8 US dollar. So now I want to exchange my 50 USDK for 50, I mean, for dollar. But obviously there are no dollars on the blockchain. So I instead will get ADA. And how much ADA must I get? I mean, it's, I suppose 50 divided by 0.8, that's times 5 divided by 4, that's 250, 160.
2.5.
Right? Right. So last cash is, or last burns 50 USDK. So I get 1062.5 ADA. And right. And now the question is, I mean, how do we do this? I mean, is that now proportional? So I suppose because it was 100, so it's half. So the so 100 ADA are still in there. So now, I mean, half of the original 100 were burned. So collateral still 100 there. I got the 62.5, so the 37.5 you get back. So that would be 837.5 ADA plus 50 USDK. So I was able to, I mean, with the, even though ADA has dropped, I got back more. I mean, and that was possible. I mean, it was anyway possible because it was only half. But even if maybe it was bad, maybe I should have done the full, but it's fine. Let's do this again. So let me just and is the collateralization is still right? I mean, now it's 50, so it's, yeah, I think it's still fine. Yeah, I don't know. So the point is that maybe do this again. So if we do this again, so Robertino needs more help. So now I have down 6.5 plus.
I think the some it might be confusing the part where my money changed when I didn't interact with the collateral.
Why? But I interacted with it.
Yes, but my wallet changed.
Yes, because you got the rest back.
But that's in the same. Okay, I got I got my 50% extra.
I mean, we burned half of the original USDK.
So I
the
got,
other half is still there. So of the, I mean, we 100 were, I mean, 100 USDK minted basically, and now it's only 50.
so
So
the collateral is still 200. It's still 200%, 100% on top, or like 200%.
no, because the price dropped. So now, I mean, the 100 ADA that are still in there are now worth only 80 US dollar. So it's 80 to 50. So it's now 8/5, so 1.6. So it's 160% now. So maybe we should, like here at this point, it was 200%, right? 200 ADA at this point was worth 200% of the minted tokens.
Yeah.
So now, because the price dropped, the 200 went down. So now it's only 160%. But that's still fine. That's still above 150. I mean, we don't need this row actually. I just want to do the same thing again, but we can delete that again.
But these are the contract now has the functionality of you being able to burn, and
Yes,
when you burn, you are giving me, the rightful owner, a
the rest.
100%. I mean, the collateral correspondent to whatever the amount you burn.
No, I mean, I give you the rest. I mean, so first of all, I mean, because I'm only talking about 50, we have all of that. So it's 100 ADA collateral for 50 USDK.
Yeah.
And now this 100 ADA collateral gets split between you and me. I get the worth, which is 62.5, because at this point it's worth 62.5.
Mm-hmm.
And you get the rest, the
Okay.
over collateralization.
Perfect. Yeah.
So
Okay.
so the point is that I mean, I get exactly what I want to get. I get 50 US dollars worth of ADA out of it.
Perfect. Yes.
And the reason I can do that, I mean, even though the price dropped, is because of this over collateralization. I mean, if that wasn't there, if you had only put 100, I mean, yeah, I mean, probably we should do it again. So Robertino, sorry. Again, so again, I get 162.5 data.
Plus, like,
Plus 50. You now have ADA 37.5 ADA. And this is unchanged. I don't know, should we change the price again?
I think the point will get across without changing the price, but maybe then we can increase the price of ADA, which was one of Tony's.
Should we increase it now? Yeah, okay, fine. So let's say ADA rises. So now let's say one ADA is 1.2 US dollar. Okay. Okay, and I want to burn. So now I should get, I mean, this is, what is that? That's 6/5. So I should get 5/6.
60? 60 ADA? Or
No, no, and now I must get less than 50 ADA. I think 250 divided by 6 is 41.
0.67,
Yeah,
42.
yeah, let's say 42. So I get 42 ADA. So I have 1,100, 4.5. I mean, this is like roughly. And you now get, okay, fine. So I get 42 of the remaining. So you get 58. So you have, geez, 800. Is it 95.5? And this is gone.
Okay.
And I mean, the problem as we see here is that you lose money because you are basically taking the risk of the fluctuation. I mean, you started with 1,000. No, oh, no, that's not to say, because I mean, it's a bit weird. Did I really do this right?
No. I didn't lose anything because I actually got the
Right,
value of $1,000 by your.
right. I mean, yes, you didn't lose anything. That's right. But I mean, if ADA dropped, you would lose something, and if it rises, you gain. So basically, you are like speculating that ADA will rise. And I mean, in a real system, I mean, first of all, this is the idea that because of the over collateralization, no matter what ADA does, I always get the correct amount of ADA out in exchange for my USDK. So there is, I mean, the point is there is enough money in the collateral to, no matter what ADA does, to pay me back. As long as ADA doesn't drop too dramatically. If it drops too low, then maybe there's not enough collateral to pay me out. But for that, there's the slashing mechanism. So if the collateral drops too low, then anybody can take it, which incentivizes Robertino, because obviously he doesn't want that, because then his money would be gone, to make sure that there's always enough collateral in the collateral. So that's the slashing mechanism to incentivize him to keep enough collateral. I mean, to make sure that there's enough ADA. If somebody wants to cash in the USDK, that there's enough ADA, no matter what the exchange rate does. But if the exchange rate fluctuates like not too much, then at any given point I get exactly the right amount out in ADA. I mean, corresponding to the current exchange rate. And I mean, we see there's, I mean, like two different, I mean, there's me. So I'm only interested in having a stable coin. So I want like this USDK. I want to guarantee that I always get like $1 for one USDK, or rather the corresponding amount in ADA. And then there's Robertino. So Robertino is like plays a different game. I mean, he will make money if ADA rises, and he will lose money if it falls.
But
Because,
how they lose money if it falls?
well, if, for example, I mean, if we do this again,
If it falls above 100%, for example, if it goes to 100%, no, wait.
no, let's can I somehow copy this whole table?
Yeah, try highlighting like if it was text, maybe. Ooh, fancy.
Right. If we do it again, but now let's say 50, you pay me 100 here. So I have 100 USDK. I mean, the point is,
And I have 800 ADA and the collateral.
well, let's say you don't hire me. I just buy last buys 100 USDK from Robertino. So I have 900 ADA and 100 USDK, and you have hang on. So you have 900 ADA and
I
no USDK. So you send me everything, all you have.
Yes.
And now ADA drops and I burn 100. And let's delete.
Yes.
Right. So what happens now? So I must get what is it? I have 100 USDK. It's now worth 0.8. So I must, it's 4/5, 5/4, 500 divided by 4, 125. So I get, so I have 1025 ADA. So I get my, I mean, the 125, the correct amount of, so I'm happy. But, and what is with the collateral? So the 200, I get 125 out of it. And you get the rest, so 75. So you have 975 ADA in the end. So you lost 25. You lost basically that because the cost dropped.
Right.
And that means in a realistic, and of course, if it went up, it would be the other way around. If it goes up, then I mean, I'm still happy because I still get like $1 for $1. But then you would in the end basically end up with more ADA. I mean, if I get less than 100 out, then you would get more than, I mean, if you do this again, sorry, you do this again. Same story, but now it goes up, ADA goes up. So now my, what was it? So it's now 5th, 6th. So instead of 100, I get 5/6 of 100. What's that? 83.333.
Yeah.
So I end up with 983 ADA, and I'm still happy because I mean this is, I mean the 100 USDK are worth 83 ADA at this point. But you now have 1017. So you end up with more in the end than you started with. So that means, I mean, this is the basic mechanism, but there are some parts missing. I mean, basically, you have a risk. I mean, you are a speculator. You speculate on ADA, that ADA goes up.
Yeah.
And somehow I mean, at the moment, there's no risk or nothing, no downside for me. So in a realistic system, I would have to pay for that. I mean, for the privilege. So I think each time I do this burning, for example, I would have to pay a certain percentage to you. That's like why you, I mean, why you would be doing that. You accept the risk of a cost fluctuation, but for that you get like payment from people that use the stablecoin. And I think in like actual stable coins like Jet, that's built in, like this rate that you get. I mean, you have to. I mean, on a real exchange, you also have to pay a bit for. I mean, if you exchange, so I mean, there would be fees involved.
Yeah.
each. So I think in Jet, if I remember correctly, there are these two roles. So there are the people that basically speculate on ADA going up. So they have a high risk, but also like high potential for rewards, and they get paid by the suckers. I mean, by the people that want stable coins. So basically, I mean, in this picture, I'm like the conservative, careful person. So I just want it to be stable. But you have like the potential to make money, but you also have the potential to lose money, depending on what ADA does. And there, I mean, some of the incentives have to be set right to make this work.
Yeah. Yeah. Maybe yeah, I mean the fee is like the amount of the fee is key as well. Like 1%, 2% makes a whole difference.
Yeah, so probably you would charge me 1% or something. I mean, you would sell the USDK not for like $1, but for $1.01 or something. So that's why you would take that risk.
Okay.
So I think that's basic. But I mean, the main idea is this over collateralization that is guaranteed that even if ADA drops, there's still enough collateral floating around to make everyone happy, so everybody can cash in, and that gives them I mean, probably in reality they never will cash in. I mean, it's the same as with I mean, like fiat currencies. I mean, traditionally they were backed by gold, for example, right? I mean, you got a gold coin, and in principle it was worth as much as the gold contained. And even these days, I mean, certain currencies are still backed by gold. So in principle, I could walk into a bank with I mean, in theory, with my euro and demand gold in exchange for that. And I know, I mean, I trust the money because I know in principle it's backed by something that has value. Although in reality, of course, after centuries, people using money and trusting it, I think in these days it's not backed anymore. So it's just psychology because people believe it's worth something. And I suppose it's the same with these stablecoins. So nobody or most people will never exchange it for ADA. But just the fact that they could basically gives them the confidence to trust that it actually has the value of $1.
Does that make sense, Tony?
Your audio quality is very bad. I unfortunately couldn't understand anything. Would you understand anything, Robertino?
No, but
But Tony said in the chat, thank you so much.
Oh, okay. Very welcome. I hope it makes it clearer.
yes, and feel free to, like, if you solve the microphone issue, you feel free to talk. Yes, amazing. Yeah, it says that it makes sense. Awesome. I'm glad, Tony. So, yes, do we have any more questions? Maybe we should take a break.
Yes, we should probably take a break until, I don't know, 4:05.
Sure. Yep.
Okay, let's take a break.
See you, everyone.
See you.
Yes, and we do have a question. I will going to read it out loud, so it's in the a question. In the example that we had an instance where Lars was paying Robertino 50 USD Kenya. Now, if we assume that the value of ADA didn't drop, then if Lars tries to cash out the 50 USDK, he will only get 50 USD in the form of 50 ADA and not 75 ADA. In parentheses, 15 ADA serving as the extra collateral. Is this correct?
I'm just a bit confused because I never paid Robertino 50.
Yes. So when right. When Lars, I think he means when Lars cashes out
Uh-huh.
SDK. I mean, Lars always gets the equivalent value of USD. So if one ADA is 1 USD, Lars will get 50, like the same number, 50 ADA for 50 USDK.
Yes. I mean, here, I mean, in these two examples, I cashed out 100. And when ADA was 80 US dollar cents, I got 125 for my 100. And when ADA was 1.2 US dollar, I got 83 for my 100. So I always get the correct amount in ADA.
If the price doesn't change.
And if the price doesn't change, I would get 100. I mean, I always get like the correct amount corresponding to the correct US dollar amount, taking the current exchange rate, the ADA, into account.
That makes sense, Tony. Doesn't matter what. Makes sense. Doesn't matter the relationship between ADA and USD. Lars will always get the equivalent value.
Okay, right. Yes. Okay, cool.
So, any more questions or projects?
You can ask anything you like. As I said, I mean, can be related to more recent topics, but also anything Haskell or Bluetooth or Malo.
We have a question.
Yes.
Samson.
Question. I don't know if you'll tell me. I wanted to know how we would go about using blockchain to maybe save data as opposed to using it to transact. So maybe I have a health application that I would like to save my user data on a blockchain as of, for example, a user's vitals, their blood pressure, the height and their weight. I want to save them, and then when they go to the hospital, we update their records and we're able to kind of use it like that. Is that a possibility?
Right, good question. I mean, Cardano, for example, I mean, you can store small amounts of data in, for example, the datum, or also there's something called metadata. So each transaction can have metadata associated with it. That's more or less free form. But that is only small amounts of data. So actually, I mean, depending on what, like probably the datum would be, I mean, like if it's just like basic data about a person, it might even fit into their into the datum. But I think that's, I mean, apart from privacy concerns, I mean, probably people don't want their medical data publicly on a blockchain. It's also not really meant for that, and it's only small amounts. So there are restrictions on how big the datum can be. So I mean, what people normally do is that they only store the hash of data on the blockchain. And then it's more, I mean, so it's not used as a storage medium. It's more used like for verification and auditability. So that means you would use another system to store the actual data. I mean, traditionally something like this, is it IPFS, Interplanetary File System, right? IPFS, so there are like systems like this IPFS where you can store actual data, and it's also decentralized and I mean trustless and so on. So and then you would put only, I mean, if you somehow need to manipulate it on the blockchain, or there's some smart contracts involved, or traceability or auditability, then you would store the hash of the datum, because the hash is like a short byte string on the actual blockchain. I mean, of course, it depends on what exactly you want to do. But I mean, for example, for things like I mean, if for example, a patent or stuff like that, if I want to prove that, or that certain idea or something, I want to make sure that, I mean, whatever, or I write a song or something, and I want to basically claim ownership for that, I could put the actual song on IPFS, for example, and then just take the hash and put that on the blockchain, and then later I can basically prove that, see, at that time in this block, I had the hash on the blockchain, which basically, because I can then produce the document and people can verify that it hashes to this value that basically I at that point had that idea. So that's, I mean, what people normally do, that they don't store the actual data on the blockchain, but instead a hash. Because I mean, the point is, blockchain is horribly inefficient. I mean, you use thousands of computers, and all the computers have the same, I mean, have exactly, more or less exactly a copy of the same data. So it would just not be feasible that to store large amounts of data, like the medical records of millions of people. I mean, then those medical records of millions of people would be replicated on every single Cardano node, basically, which just not feasible. I mean, there you need other techniques like sharding or something that only, like, I mean, you want redundancy, that it's not just on one computer, because if that computer breaks, then the data is gone. But you don't want to replicate it millions of times either. So you would need other. So that's not what blockchains are designed to do, at least not current blockchains, to store. It's more for, yeah, verification and auditability and things.
Right. Yes, that's actually very helpful. Thank you so much.
Welcome.
A question.
Yes.
It's not that technically related. So maybe you can let us know if possible, if this is possible by you to explain the initiative that I saw recently launched by IOG in regards to the stablecoin venture. What would that entail? I think it was announced about 3 days ago.
I'm afraid I'm not aware of that. Do we have a link or something? Or Robertino or Karina, did you hear about that?
Let me share it on chat.
Uh-huh.
Heard about it, but I have no real knowledge about it.
Okay, let's see. Let's just open the link. Always so glad when I'm accepted as human. Right, let's see.
Yeah, I don't see any explanation of, I mean, it's a stablecoin venture, but
Right.
the
I
algorithm.
mean, IOG is now trying to diversify a bit and also use the spin-off model. So instead of doing everything ourselves, like until now, we're spinning off other companies that do like specialized things. So for example, there's this, I mean, you met John O'Connor while we were in Nairobi. So he is the CEO of one of those spin-offs that's somehow supposed to do real fi in Africa. And similar, we're spinning off other companies, and it seems this is one of those. And they are then supposed to concentrate on specific aspects. And I mean, we do have this stablecoin paper. I mean, like one of our researchers came up. I mean, I'm not sure, Robertino, I think it's not exactly what you presented. I think it's a bit more complicated, but basically a provably stable coin. And and I suppose that, I mean, that they want to do that for real now and actually create one. I mean, there are like several attempts to create stable coins on Cardano, but as far as I know, none of them is very popular. So maybe they want to do it properly now. So I assume they want to use that idea, this JEP thing,
Yeah.
and turn it into a real thing. But yeah, yeah. So it's a spin-off of us, but I also don't know exactly what it entails. But I mean, this year, this JET, I think
Different.
we wrote the paper originally, one of our researchers.
Yes, we did.
Uno.
Thank you.
Yeah, but
It's
welcome.
relatively low. Like like the launch was this year, so I'm not sure exactly how it will impact the ecosystem like 3 years from now. But at least paper is there, so I mean, I'm guessing more people could implement their own versions and stuff.
Yes, I think there, if I remember correctly, there were also legal issues. I mean, if you do a stablecoin that's like legally very critical.
Yeah.
So I think one idea was that basically somebody comes up with the algorithm, but then you just open source the algorithm, and then whoever wants to can take it and create a stablecoin. But yeah, I mean, in principle, similar to what you did now. I mean, now people could do this. Principle.
Yeah. Don't steal my idea. I'm just kidding.
Thank you. Thank you.
Welcome. Are there any other questions? That's that. Oh, Karina, what did you share?
I shared the paper for the DJ.
Oh, yes. Thank you.
Right.
So efficient. I wanted to look for it, but you have already done it. Actually, Javier Diaz, he was one of my students on Barbados. So when we did a similar class to the one now, he was one of my students. So maybe you will write your own stablecoin papers also in 3 years.
Yes.
I think that's Tony asked for relevant resources for implementing stablecoin. I think this one is like the one Lars has open, Karina share is like one of the best we could share.
Yes. Yes, and as I said, I think it's a little bit more complicated than the one you presented, because I think there are like 2 different coins involved.
Yeah, exactly.
One
Yeah,
is
no,
this,
it's a more thought through algorithm.
is one is the actual stable coin, and the other one is like a speculation coin, reserve coin. But yeah, so I think, yeah, that's the paper that Jet uses. It looks very mathematical, but and there are also diagrams and stuff.
That's pseudocode or what's
This looks like real code, but
yeah.
I think it's the I think it's the formalization. So like the formalized proof that it's actually works.
Right.
Probably Isabel, or not sure what it is. What proof assistant?
Mm-hmm.
Anyway, so they formally proved that it's stable, I suppose. Yeah, in Isabel.
Yeah.
Okay, and there's also bibliography. So I think, yeah.
There's more than enough. Yeah.
So there's more background on stablecoins, I think. Okay. Yeah, so there's everything. Okay.
Anyone has any other questions about projects, Haskell, Cardano, Bluetooth, Atlas?
I have a question about costs, like transaction cost, and how operations such as fold and map and fmaps, like how do they affect the costing? Is there a good correspondence between the two?
Sorry, you operation costs? You mean transactions on the blockchain?
Oh yeah,
or?
yeah. Is it, yeah, no, yeah, and also how do they correspond to like Haskell operations such as folds and scans, like those recursive operations? Are they expensive?
Right,
Are they cheap?
right. I mean, in principle, I mean the way Plutus, I mean Plutus gets compiled to this Plutus script, and then there is something, I think it's called CEK machine. That's like an abstract machine that actually executes these programs after they're compiled. So, and somehow then there are like different steps. I mean, so I mean, in principle, I mean it obviously runs like on a laptop or like on the Cardano node. It's like implemented in Haskell, but I mean they basically simulate executing these Pluto scripts on some virtual machine, and there every execution step basically comes with a cost, and how expensive various, I mean, and of course it's like all sorts of, I mean, whatever, it's arithmetic operations and memory allocation and comparisons and cryptographic operations and all these things. So it's dozens or even hundreds of different, let's say dozens of different operations, and they all come with associated costs. And there's like a cost budget. So when you create a transaction on Cardano, I mean, you include transaction fees. And I think you also, I mean, you never have to, normally you don't have to do that manually, but in principle, you also include a budget. So for, I mean, the number of execution steps and these transaction costs. And then basically the Plutus program is executed, and you must, I mean, if it would take more steps than are in the budget, then it just fails. And if the cost of the steps is more expensive than the transaction fees you include, then it also fails. And there are like limits for that. And in principle, one can look at that. I mean, there's actually, I'm not sure whether I have just see. If I share my screen again. Second. Let me just see whether it works. Just want to, I think right now it doesn't. I normally have a running node, but I think right now that I can't connect to it. I just wanted to show these parameters, but it also doesn't matter. Maybe we can look Cardano node parameters. Right, there are these protocol parameters, and here's somehow three structures that there. Oh, this is primitive. No, I think this is just high level. Second, if I just look for Cardano node, I think somewhere there are these parameters. So here. Right. Not sure is the other. I just wanted to look at parameters, but it's not in the node config, right? No, and this is just the node itself. It's, okay, there it could be actually. Alonso. Yeah, okay, right. This is what I was looking for. So here are these so-called cost models, and here you can see a long list of stuff, of steps that can happen. So, I mean, I never looked at it in detail, but for example, this is like to compare two strings for equality, or to get the head of a list, or to get the length of a byte string, or whatever. And they all have these parameters that, I mean, are protocol parameters that can in principle be changed. And right, so that's how it works. And they have been tuned somehow to reflect actual costs. So I mean, ideally, I mean, they reflect how expensive it is to, or how much time it takes to actually do these steps. And so yeah, that's how it works in principle. That I mean, when a Plutus program is executed, it gets compiled or interpreted, and then I mean, each computational step is one of these, and the corresponding costs are accumulated. And I mean, that's how much you pay. And then now to come back to your recursion and so on. So I mean, recursion is just, I mean, done, and I mean, it's just like flattened out or unrolled into these steps, and then they are counted. And I mean, just to give, I mean, it's a bit hard to say, but I think a transaction, a normal Cardano transaction that doesn't involve any Plutus, just one person sending money to another person, what is it? It's like 0.28 or something, maybe, transaction fees. So the lowest possible transaction fee you can get. But then if it's like if it involves complex smart contracts, and so I mean, I think it doesn't. It's never much higher than, let's say, 1.5 ADA. So it's maybe, I mean, and if it was even more complex, then it would probably be too big, and because there are these limits, the number of execution steps is limited, and the memory consumption is limited, and the size of the contract. So I think it's like, no matter what you do, it's never more expensive than 1 ADA or so for this. So yeah. So you can do folds and recursion on the blockchain as well. Normally, I mean, everything is quite small. I mean, the lists, I mean, you have this list of inputs and outputs, for example, that your validator might want to loop over or fold over, but they are normally short. I mean, relatively short. I think a transaction, I mean, in principle, like in theory, it's unlimited, but I I think the biggest transaction I've done has like 100 outputs. So it's order of magnitude of that, like normally like low 2-digit numbers. So it doesn't get crazy, the recursion. I did hear something interesting though. I think there's this project on Cardano, I think ZK Fold, that started yesterday or very recently. And they do use something called zero knowledge proofs. And I think, or at least they claim, that they now can do something like they can do computation off chain. So basically, your Plutus programs can be as complicated as you like, and so you can do arbitrarily much computation. And then for the nodes to validate it, they don't. I mean, the node doesn't have to run this complicated computation. It basically just gets a proof that the computation has been run, and that proof is like constant size and constant space and constant time to verify the proof. So if that's true, then that would mean that this is no issue anymore. So your Plutus contract can be arbitrarily complex, and basically on the blockchain, all you need is to include a proof that can then be checked in constant time. That would be really cool if that's true, because that would mean we wouldn't need to worry about costs of Plutus execution any longer. Because right now it's relatively limited. I mean, it's better than it used to be. So in the beginning, when Plutus just came out, you very quickly reached the limits that you ran out of your execution step budget. So you couldn't do very complex things. I mean, that has been, I mean, Plutus is more efficient now. So you can do, and the node is more efficient. So they have increased these limits. So Plutus programs can be bigger and they can take more execution steps. But nevertheless, you relatively quickly can run into these limits. But with the zero knowledge proof stuff, that wouldn't be an issue any longer. So you can have arbitrarily complex Pluto scripts basically without any cost, additional cost. But yeah, so in principle, I mean, you do use folds and recursion in Plutus programs as well. So that's fine normally. I mean, I'm not sure whether we saw an example, but often you have to, for example, look at all, I mean, for example, with this atomic swap I did, I mean, you have to, I mean, the validator checks that there's a payment output, and so you have to loop over all outputs. So that's very common in Plutus validators, that you do a fold over the list of outputs, for example. So yeah, that's common that you use recursion in that sense. Does that answer your question?
Yeah. The page on the screen is pretty helpful. Like yeah. I think the numbers represent what each computation will cost in time, I mean memory or something.
Yeah, I think it depends. I mean, here's something with slope. So that's like, I mean, it's like a line. Sorry. So I think it's not necessarily fixed cost. Sometimes it depends on like the length of the argument or something. So it's like a factor. I mean, here, for example, it says slope and intercept. So, I mean, this like specifies a line in 2D. So then if it's slope and intercept, then basically depending on the size of the arguments, I mean, it's like the intercept plus argument size times slope. And I mean, I also don't know exactly what the unit is of measurement here. So that's just some virtual unit. I mean, it's not ADA, or not necessarily ADA or Loveless. Maybe it's Loveless.
It says CPU everywhere.
Yes, CPU, yeah.
But I'm not sure if it's like.
Actually, I share some. This is an article, but it's a little old, it's dated, but have some table with the explanation about the parameters for calculate the total cost for the.
Yeah, that's a good link. Thank you, Karina.
CPU units, but
yes, and then somehow that must be like calibrated to correspond to actual cost.
Yes, with the actual cost for the model cost. Is this the cost, the actual cost? Is
Oh yeah, but here you also see like the maximum. So yeah, that's what I said. So if it doesn't involve any Plutus, it's like what I said. I mean, I said 0.2, so it's 0.17 is basically the lowest transaction cost you can get, and the maximum seems to be 2 ADA for like addition to that. And here they have like a complex script. I mean, it's still relatively cheap. Whatever they call complex, and like the simple most, this very first example we had in Plutus is almost for free.
Yeah, I think that's everything I wanted to know. In that,
Great.
in that table. Yeah, thank you.
Welcome. As well, in my experience for normal Plutus contracts, that like with normal stuff like DEXs, it's like yeah in this range somewhere, like 1 ADA or so. So at the moment, of course, because ADA is so low, I mean, actually, ADA is, I mean, the price of ADA is low. This is all very, it's all ridiculously low. Of course, it's all-time high when ADA was almost $3, was $3. It was relatively expensive. I think have also been, I mean, people have been discussing to somehow pay transaction fees not in ADA, but maybe in a stablecoin or so. But I mean, that's far in the future. But that would, of course, be nicer because now it depends on the exchange rate how expensive transactions are, which is a bit bad. But anyway,
It's all fertile ground for you to do your own research and expand ideas and try things out. Now that you have all the knowledge to get started.
yes, exactly.
I have a question.
Yes.
There's a network that's called Midnight Network. Any idea of how it's supposed to work in regards to data protection and all these kind of compliance issues that they want to bring into Cardano?
I mean, I'm not as I said, not a cryptographer, but I think it's like basically everything is completely private. So I mean, I think you can't see who has how much, and you can't see how much you sent and where you sent it. So everything is, I mean, my understanding is that basically you can get zero information out. So nobody knows who sends what where.
I mean, we don't know about the regulatory issues surrounding that, but the technology, I mean, is supposed to be completely 100% private, and like zero knowledge and stuff like that. But yeah, I'm not sure if your question was purely technical or not, Anderson. If it's not, you're not in position to answer.
No, it wasn't like purely technical, just because I saw that network being advertised. So I didn't and I didn't know the background behind it, like what was the reasoning why it's something that like there's no clear picture of how it will be adopted in the long run. So maybe I thought maybe you had an idea, but it's okay. It wasn't a technical question, but thanks.
No, I mean, I think the motivation is privacy, because I mean on like Cardano, but also on Ethereum or on Bitcoin, like on most blockchains, even though I mean everything is just public keys. I mean, or key hashes. I mean, you only see the key hashes, but nevertheless, it's possible to more or less identify who is behind it, or at least in many cases. So in principle, I mean there are these tools like Tap. Is it called Tap tools for Cardano, for example? And I mean there are companies that basically trace money flows, and so it's relatively easy to see on Cardano or other blockchains. I mean, who has what and who sends what where. And of course, that's, I mean, in one sense, it's nice. I mean, everything is fully transparent and so on. But of course, for certain applications, it's also, I mean, you don't want the world to know whom you send money. And so there's definitely a need for, or a requirement for, or desire for privacy, where people don't see, I mean, how much money you have, where do you send it, from whom do you receive it, and so on. So I think that's the motivation behind it. I think IOG has been working on that for many years, but like in different incarnations. So, I mean, and I don't know what now finally they're settled on. I mean, at some point it was supposed to be like a sidechain to Cardano, so I'm not sure whether it still will be a sidechain or whether it will be completely independent. Actually not sure, but I do know that I think in January or so, they plan to their first testnet. So it's coming relatively soon, I think.
Yes, you can already sign up to be like a dev tester of the like a developer, testing developer. So you can already start using it and try it out.
Okay, good. Yes, so it's supposed to be completely private, everything. So I suppose no blockchain explorers then? Not sure.
Yep.
Any other questions? Anything still, I mean, can also be Haskell, anything you still want to ask? Today's basically your last chance. I mean, of course, you can still ask on Discord or so, but
We might be busy doing this somewhere else and answering someone else's questions.
right.
Sorry, in the last class, we talked about this commonality, right? And
Yes.
there's a way to associate like the element you're viewing and what's on the left or the right. Like there's a directional aspect to it, to that relationship. Is it like what will you do? How do you go about instead of having that directional relationship, you have like another kind of relationship, like let's say you want to relate things. Like let's say in a graph, you can relate nodes which are next to each other or a tree relationship. How about if you wanted to go more arbitrary than that? Like you want maybe to relate things which are, let's say, okay, a good example is like in chess, right? You want to relate two pieces together in a certain way, in a certain arbitrary way. Like how do you go about doing something like that?
I mean, do we have like a specific use case or like application you're wondering about?
Yeah, maybe that. Yeah, the best example I can think about is in a chess implementation, right? Like
Yes.
every piece is in some ways the center. Like if you look at that particular piece, like you can think of it as the center, like not the center, the element you're viewing, and it's related to all the other pieces in some like in the last class we were looking at lists whereby you have like a middle element and then you have a left list and you have a right list. So in the case for chess, you're looking, let's say, like at a pawn, and then you want to see how it's related to like everything else on the board, right? Like yeah, so how do you go about something like that? Using a component or something like that.
Right, good question. But I'm not sure chess is a good example because I mean it's still this. I mean, because in chess the pieces are different. I think you still need something, a container of like equal same things. I mean, in my example with the left and right with the tape, I mean they're like the same type of thing. Like in my case, booleans was in every cell of the tape. And I mean, chess of course is different because they're like different pieces. So I'm not sure that.
Maybe if we, instead of looking at the piece, we look at the state of the board, and we have the past and the future and the current. But I'm not sure if you can make a decision based on that, because like it has an or a predefined order, so you have to like figure that out before. Yeah, I'm not sure if that's useful actually. So it's a single element, the state of the board. But I'm not sure. I don't see it being useful, at least what I'm imagining it.
Right. I'm also not. I mean, obviously, with this left and right, you could, I mean, easily generalize that to like 2 dimensions. For example, if you wanted to do Conway's Game of Life, I mean, that would be very similar, of course, to what I did. But, and I mean, graph, I suppose you could also do. I mean, I also, I mean, as I said last time, comonads are not that commonly used. So I don't have such a good intuition like with monads for comonads. I mean, except that it's dual. I mean, I read this morning a bit on comonads, and I mean, they said like monads are all about putting values into a context, like and comonads are extracting values from a context, whatever that means. But I mean, we saw this example. So in a comonad, you can always extract value from it. But yeah, and also maybe one thing I can say is, but that doesn't answer your chess question, of course. Just sorry. Just that trust myself. Just wanted to say that there's also, I mean, we talked about free monads, and there's also there are also co-free co-monads, and that's maybe another intuition for or like an example for co-monads. Let me see whether I can get that right. So co-free F. Do I get that right now? Let me see. Sorry. Right. This, I mean, one possible definition. and he just writes it differently. Yes. E. Oh yeah, okay. Right. So it seems to accept it. Just as a reminder, so how was that data? I mean the free monad was like this. I'm not sure whether we called it free or bind, but I mean this was free monad, and we again see this like duality between the two. I mean we had this pure and this bind, which was the functor applied to the thing. If we also have the functor applied to the thing, but instead of a sum, like two cases, it's now a product of two. And here you can immediately see, I mean, of course, the point is that that if f is a functor, then we have a comonad of co-free f. And extract is just, I mean, this first element. And is this correct? I think this is not correct. It's like, right. Think like this. So that's the implementation. And there you can also actually, if you now take concrete functors, so for example, what can we do? For example, if we take maybe, so co-free maybe would be A, and then maybe co-free maybe. So that means co-free maybe is a non-empty list. So you always have an element and then maybe something else. So that would be non-empty list, which is interesting that basically non-empty lists, I mean, they do exist. There's, I think in base, no, or in container, there's a non-empty type, but which is basically like, I mean, it's not like that actually. It's not implemented like that, but it's equivalent. Or what happens if we take co-free list? I mean, I should say A. So that's A, and then a list of A's. And that is actually what we in our examples always called a rows tree. So that was exactly the definition of rows tree. I mean, we gave another name to the constructor, but it was like one element in the node and then a list of branches or of children that are again recursively rows trees. So it just shows that that basically data types that we already know and used as examples, they appear as they are actually comonads, and not only comonads, but like co-free comonads. And I mean, you always see that, like you have, I mean, this one A that's in focus, and then like the rest that is specific to the comonad. And but I mean, and I mean, here you also see it's not necessarily left and right. I mean, whatever given by a functor. And I mean, the same thing as you with free monads, you can like write interpreters from free monads into other monads. I mean, because all the errors turn around in comonads, it's the other way around. So you would be able to write something from an arbitrary comonad into that then. But What else can one say? I mean, one can try other functors, of course. Let's see. And I mean, regarding, I mean, chess, I honestly don't think that's a good example, but as I said last time, I think another classical example that people use is like menu systems, where you are with the focus on the part that you're currently at. And then, I mean, it wouldn't be left and right, it would be like navigating, like going up one level or going to the next chapter and things like that would be the possible moves. I'm not really sure what else to say about commonards. But I mean, why are you interested in that? Do you want to like implement something with commonards, or are you just interested in chess? Want to write a chess program?
I'm interested in, I'll say both. I've been trying to, I've been implementing this chess program, but then I want, instead of just playing chess, I want the program to explore the moves in a very, I don't know, nice way, interesting way. So when I saw
Right.
commonards about like infinite stuff, I thought maybe they'll fit to that kind of thing. Like, let's say you're like, I don't know, Robertino says something like, you have a current move, okay, the current state, and then you have the previous states and the next state. So
Right,
there's
right.
that relationship. So I think I wanted to see if it's a good idea to use commonality to explore like any sort of quote unquote world, like could be chess, could be like any kind of custom world. And then you have that kind of exploration, because
Right.
the
Actually,
infinite.
I think this rose tree, this you could, I mean, you have this concept of game trees, right? Where you have a current position, and then you have a list of possible like follow-up positions. So I mean, you could certainly use this. It's actually maybe not a bad view to, yeah. I mean, in that sense, it has something to do with games. So basically, you could, I mean, this in principle defines a game. I mean, A is like the type of game positions, and then this list is the list of possible moves or the next positions. And I mean, chess would also fit into that. And if basically as a position is finite, I mean, because one of the players has won or there's a draw, then this would be the empty list. So you could represent any game, not just chess, but basically any more or less arbitrary games in this data structure. That's actually true. And I'm not sure whether the Comonad structure helps you there, but it might, I suppose. Yeah.
So just a question about on Internet. So the relationship between any kind of the viewed element and the surrounding elements depends on the structure in which you're making it an instance of commonad, right? Like so in the case for maybe the way the center element is related to other elements is, okay, this is coffee, okay, not the coffee man, not the coffee one, maybe like the stream, not the stream, the tape, the tape thing we had.
Yes.
Since the structure defines three things, and we made that structure in terms of commonad, the relationship between any two things will carry from the structure. So does this apply to every other data type you'll have? Like that relationship is maintained somehow. Is that a good intuition? Like, think about.
I'm not sure. Maybe it's specific to this type of thing. I mean, actually this tape was an example of like a special type of comonad called zipper, which is like moving around in a data structure, and that is, I mean, there you have this intuition that somehow the ways you can move are intimately related to the data structure itself. But I think that's like only like certain types of data structures. I mean, actually, zippers are also a fascinating topic. That I mean, for example, I mean, you can even do like differential calculus with data types to get zippers. But I mean, another example for the zipper thing would be let me see. I mean, we always had this tree type data tree A. We had data in the leaves, right? So we had leaf A or node tree A. And so in a tree, if you, I mean, what can you do? You can, let's just 1 second. Right. Yeah, sorry. I was just thinking, I mean, this is related to like, yeah, I mean, you have this, sorry, you have this data structures like lists or infinite lists or trees. And I mean, and now let's say you want to, you want to edit such a structure. I mean, write an editor for it, for example. I mean, in imperative language, if everything is mutable, you can basically have a pointer to like the head of the list, and then if you want to edit the list, you can like move to the right or to the left in the list, and then like modify something in place. So the question is, what do you do in a functional language where you have immutable things if you want to, for example, edit a tree or so, and that's where these structures come in, and that's like always, I think, always gives rise to a comonad. But yes, so I think this intuition that you have, that's correct only for this specific type of comonad, where like in a tree, instead of going left or right, I mean, you could go to the left or right subtree, and or yeah, depends how you look at it, or you could go up sometimes. Right. But yeah, I think that is only specific for this example. So one probably would need more, would need to see more examples, I mean, more general examples. So that is only a type of comonad. It's not like all comonads. It's only these that arise in this way from a data structure where we want to focus on a specific element and then navigate around in it. So then indeed it somehow, I mean, there's a correspondence between the data structure and how you could move around in your original container. Like in a list, you can go left and right. In a tree, you can like move up or left or right. I mean, to the left child or to the right child. So that would yeah, be that. So
I found a chess engine written in Haskell that is quite powerful. 2020 ELO. and the code doesn't seem too threatening. So maybe I'm trying to find like some like generic data structure that they use, but nothing so far. But the code doesn't look too bad. So maybe Jason, you could like explore it, how they, yeah.
Interesting.
Yeah,
So
sure.
it's
That makes so nice. Yeah.
so it makes it's quite strong, you say, Robertino?
2020 ELO, which is professional level.
Ah, cool.
Yeah. I'm going to share it in the chat.
Mm-hmm.
I think right now Magnus Carlsen, which is the best of the best, is like 2700.
Okay.
So it's not the best, but it's close enough.
Mm-hmm. Did you share it?
Yes, in the chat and the Zoom's chat.
Yeah, I see it.
Uses transformers, MTL.
Okay, cool.
Containers. Yes.
Not bad. You say the code doesn't look too bad.
No.
Okay. Interesting. I'm trying to think whether this game tree idea, whether that has anything to do with comonads. I mean, whether the comonadic structure somehow helps one there to do things.
No idea. I have like almost zero experience with components.
Mm-hmm. Yeah, I also have very little. I mean, it would be interesting if one could do something like min-max easily somehow.
Right. No, I don't know.
Right. Yeah, that was this. Ah,
If someone else has any questions while I search for types and Lars try to figure out the example.
I'm wondering whether something like like tic-tac-toe or so. One could, I mean, what's an easy game that one can handle basically?
You mean because of the possible permutations, of the next?
Yeah, but I mean, it of course doesn't necessarily have to be a board game. It could be any two-player game. That's relatively simple. It doesn't have to worry. I mean,
Rock, paper, scissors.
that I mean, would be better if it doesn't involve randomness.
Yeah.
I mean, something. I'm wondering whether something like NIM or so is feasible. Also,
Samsung just suggests truth or dare.
um,
I don't know. Maybe tic-tac-toe could work. We do need to. I mean, once we have the first move, there's always the best next move.
right. How would you represent a tic-tac-toe I mean, fine. I mean, how would one? I mean, I suppose one can start with. One can start with importing vector, I suppose. Or one could just use lists for simplicity.
Yeah, and yeah, we can represent this as a flattened matrix.
Yeah, or maybe yeah, flattened. Yeah.
Or maybe just the like a 2D matrix. But maybe that's going to be a bit of a hassle to like iterate over. Like,
Yeah, I'm trying to think whether one needs vectors or arrays, or whether lists do are fine. Suppose one can get away with lists because it's such a small example. And one would start with like player X or O. And the board could be, or position would be the board would be just a list of lists of maybe player, and then maybe to move or something, the player. Right, so I don't know, is there somebody that always starts? Does X or O always start? Or
no, but we could like choose that. I think that's not
okay.
an issue.
Copilot is just okay. He now shows that X always starts. Fuck.
The AI is in charge.
Yeah, it's somehow depressing, but anyway, right. And right now we want the possible moves. So So first of all, I suppose we must find out whether somebody has won, right?
Yeah.
So has one player position, or actually I should sorry, type board that, and then player board bool. So now do that Copilot. Not bad. Okay,
Um,
okay, it doesn't know transpose, but
No.
Oh, no, that's bullshit, I think. Oh,
yeah.
no, it's actually not bullshit. That's actually anyway, maybe we can do some work ourselves. Okay, so first, I mean, he's right, of course. Let's just, I mean, we do have the rows. So let's say the board implement the rows. So yes, I mean, the first thing was right. So if any of the rows yeah, I mean, this first condition is definitely right that he gave there. So this says, I mean, so we have the 3 rows, and if in any of the 3 rows all the cells are just P, that means he has a row. Now we need the same for the columns. So he does this transpose thing. I think there's an elegant way in Haskell to do that, but I always forget what that is. So, I mean, we need transpose. Bullshit.
It's in data.list.
Is it?
Looks like it. I
Cool.
just Googled it.
Yeah. I think there's one of these cute definitions for it that you can basically, it's a one-liner, but let's just.
Yeah, the one in the base library is not a one-liner,
Okay,
but maybe it's like super optimized.
maybe. So let's just see whether that works. So if I have like 1, 2, 3, 4, I mean, this is now not tic-tac-toe. I just want to try it out. 5, 6, 7, 8. So a list of lists, then transpose like turns this list of rows into a list of columns. So yeah, that works. And then this is probably correct. So the first line says, I mean, that one of the rows has 3. Then do the same for transpose, which is all the columns. And right diagonal, so that computes the diagonal, so the one from upper left corner to the lower right corner. So that looks good. And then the last one must be the other diagonal, so it just reverses the rows. Yeah, I think that's correct now. So it's like very depressing that Copilot can do that. Okay, anyway, so that checks whether there are 3 in a row. This checks whether there are 3 in a column. This checks the one diagonal, and that checks the other diagonal. Right, and I think with that we can and like open and now we somehow need for a given position the possible moves. So and I suppose one first needs it for, I mean, so basically put something in. So that's one ingredient, and now we need something that takes a list of maybe players and produces all the ways to make a move there. So let's say, I mean, I'm just like whatever row move or something. So player, and I have a list of maybe player. Turn it into a list of maybe player. So row move or moves. So if my list is empty, then there's no move. So, and if my list starts with a nothing, I think that's correct what he says, then I can move there or not and recursively move somewhere else. And finally, if it's already occupied, then it's this map, yeah, this. So let's try that out. Okay. So for example, if I have a row, whatever, just X, nothing, nothing, and check what O could do, then, I mean, I get that it could move here in the second part or in the last part. So that seems to be fine. And now, I mean, let's just do it quick and dirty. Moves prime. So player board, list of boards. Is that correct? I don't think so. So let's just do that. So that's first row, second row, third row. So we have yeah.
Quick question.
Yes.
Wouldn't this be a good candidate to use the list monad, like monad itself, to like generate all possible scenarios and filters for the ones that has the move that we already did, plus or nothing somewhere, and then we have all the possible moves?
Yeah, I think you're right. Yes. I think that's better. So let's do moves prime player board, list of board. So moves prime P, and the board, let's say, is rows. So first I pick a row in which I want to play. But the problem is I must, yeah, I think this is exactly what he says. So I pick a row in which I want to play, but I must remember which row it was. Yeah, okay, fine. This replace, of course, doesn't. Right, there is no replace, but but we do have. I mean, there in list there is this. What's it called? This exclamation point! Exclamation point! Is there something like that?
In list, yes. I mean, Do you mean to access a index value?
No, I mean to replace an index. So I think we need, right, replace. So given an index and an A and a list of A to list of A. So replace empty list is the empty list. Replace 0 x like this and replace n x, yeah, like this. We need this replace function. And I mean, it would have probably been better to work with arrays or something where we can do that explicitly. But so he picks a row I, then he picks in this row, he picks a column, but only one that is empty. And now we want to replace the ith row with replacing the jth column of that row with just p.
Okay, yes.
So let's see whether that works. So if I have the, so for example, moves prime x init position. What was it called? Why is init
Initial.
position? Yeah.
Affected board.
Right. Anyway, but I anyway wanted to I mean, this was moves prime that doesn't take into account whether somebody has won. So actually moves. So, and this is now just from a position to a set of positions. So moves p. So so first of, I mean, if one of the players has already won, has won xp, then there is no possible move. But if the other one has won, there's also no possible move. And otherwise, right, we need this other. So we must be able to player other x is O, other O is x. So in this case, we always have, so we look at all our moves prime. So we take a new board out of moves prime, where now it's the player whose move it is. So it's to move P, board P. And now it's position other P B. No? Other to move P, and what's wrong now?
Other expects a player.
Yes, and position, I thought. Oh, I got it. The order was wrong. It's B and it's first the board and then like this. Okay. Right.
Yeah. No, you have to flip them as well. Like
Ah. No. Where? Has one takes the player first and then the board. So why is that?
Okay.
Yeah. Oh, okay. Of course, board P. Right. Okay. Okay, and now basically that's it, sort of. I mean, now we have like now we have one step, right? We have
All the possible moves.
for any.
We don't know. We don't have the best move available for us, but we can just pick.
Yeah, but I mean that we can actually construct this tree. I mean this whole tree. So if I do again like rows, rows A. So rows tree has an A and then a list of rows A's. So now we can construct a tic-tac-toe basically. I mean a rows position exactly. Yeah, whatever. So it's initial position. Right, and now we we need a helper function. So given a position, what is the yes. So it's the one with that position at the top, and then the list is, so we have the moves P, and so we iterate F. So moves P is a list of positions. So we now map F over moves P, right? And this is F initial position. So this is basically the complete rows tree of tic-tac-toe, I think. It will be still quite large, of course.
Ooh.
But it should be, I mean, if I didn't make a mistake, it should be finite, of course.
Yes, at some point.
Yeah. And now the question is how, I mean, now we can like try to like pick a move. Quite big.
Yeah, is it that big?
Yeah.
And that sounds a bit, looks a bit,
Maybe. Looks. I mean, I think the code is fine though. It's just too big.
okay. So now
But
the question, I mean, and this means in principle, I mean, in a sense, this tic-tac-toe thing now has the full information about the game. I mean, now we can, in principle, forget about the rules and just I mean, this tree is now the complete information. So now the question is, I mean, what can we do with it? So now we could use this tree to find a winner, for example, I mean, or a winning move. I think bit where that is so big. I mean, I have no idea how many. Maybe I can just.
it's super big. 255,168 possible. Oh, you have it. I just went to math overflow. But yeah, it's a lot.
Yes, so Right, that explains why this takes forever. But it's still like encouraging that it can display everything.
Yeah.
Yeah.
Oh, oh no. I was full for a second. But maybe, I mean, once we filter for the possibles after one move, it should get manageable, I'm guessing.
Yeah, let's see. I mean, actually, this F is. Let me just promote this. Call it. Take to prime. And now let's say so let's moves initial position. So there should be 9 moves, of course. Right, and if I take the first one and now do this tick, tick. But I mean it will still be a lot if I
If we try doing like 2 moves or 3 moves, so like we reduce the possibilities just to check that everything works as expected. We can like get started after 3 moves.
right. Okay, fine. So or rather this is like the first move. And now like let's take the first one. So third one, again, the first possibility. Now let's see. Prime MS3. Why is that not scoped? Because it's fine.
It's okay. It's fine.
Okay.
Cool.
So after then it's like manageable. I mean, still big, but manageable. Right, and now we could, I mean, try to for example, we can write something like will win or will lose. Okay, fine, will win player position pool. So will win.
The response should be bool or should be sort of like a rational number, like 11 out of 1,000. Like,
I was thinking, I mean, that somehow recursively, I mean, if all the moves lead to a situation where your opponent will lose, then you will win. By playing a certain move or something like that. And I'm still trying to think whether commonards have anything to do with this. I mean, I should think that. I'm not sure.
I mean, we have wait. So we have all possible moves.
Let me just. I think yeah, we have all possible moves. So I mean, we can say we'll win P pos. So if if has won, if P has already won, then of course it's true. And if he has not won, then he will win if there's any and if any of the moves leads him somewhere where the other one will lose. So and otherwise any will lose if the other player will lose. Right, I think this is correct. And will lose. So if has won, the other player has already won, then I will definitely lose. Why is that an illegal type signature? Ah, yeah, okay, fine. Otherwise, so I will lose if all my moves will make the other player win, right? Something like this. Probably this is far too big though, because the tree is so big. So I think if I do, will win X initial. It can't be so easy. So there must be a mistake. Because in tic-tac-toe, it's also not to say that player will, you can always force a draw, right? So probably I made a mistake.
Yeah, but I think the implementation, it returns true if there's one chance of winning, but not if
No, it's meant to be that you can force a winning. So the idea was, if I have already won, then I won. And if I have not already won, then I can force a win if there's any move where the other player will definitely lose. If any of the possible moves, the other player will definitely lose.
But I'm not sure. I don't see how we can force. We have, because the other player can do like a really bad move, and we can win.
No, but it's supposed to mean that I can force a win. No matter what the other player does, I will win. That's the meaning of the function.
Right.
So if I have already won, then I will win. And if I have not already won, then I will win if no matter. Yeah, right. If there is a move that I can make, any move, I probably should take into account whose turn it is, right? And that, is somehow now confusing. I was assuming that it's my turn, basically.
You can check if there are more moves from the other player than yours, and if that's the case, your move.
No, I know whose move it is. So if I'm so if I am the one to move, then I can pick this move. But what if the other player? Right. And otherwise, yes, this is correct, I think. So right. So under which circumstances can I force a win? Either if I have already won. So if it's my turn, I can pick a move. So if any of the moves guarantees that my opponent will lose, then I will win, because then I can pick that move. But if it's not my move, then I can only guarantee a win if I will win no matter what
Yeah.
I pick.
Okay, yeah, that makes sense now. I think so. Like it doesn't matter, like all available positions you win.
Right. And with will lose, so I think there must also now, so if to move force, so if it's my turn, I will lose if
The other
no
win.
matter what I do, the other person will win. And if it's not my turn, then I will lose if, yeah. I think this is correct now. I hope. I'm not sure. I mean, it shouldn't. Yeah, and it also can't. No, there's still something wrong then. Because it must not. Because it's maybe. Actually, maybe we don't even need this will lose. I think this is wrong anyway. I think we only need this or can enforce victory. So if the player has already won, he can enforce victory. If the other player has won, then he cannot enforce victory. So if it's my turn, then I can enforce victory if there's a move in which I can enforce victory.
Right.
And if it's not my turn, uh,
the other can enforce if any of other can enforce of other player can enforce victory, then I cannot. No way. Because maybe it's a draw, and in that case, that should return.
yeah, so it's, I think probably,
Maybe we should have another case for draws. Like I said, I mean, we need the case when the other can enforce victory, and we need a case when there's a draw, a possibility of a draw.
yeah, actually, I think it's something, I mean, it's something else. Hang on. Yeah, it's silly. Sorry, we need, I mean, data outcome is X wins, O wins, a draw. And we can basically, assuming optimal play.
Right.
So if has one X in board position, then X wins. If O has already won, then O wins. So now if to move, so if it's, or yeah, to move. So if it's X turn, then what will be the outcome? If in no matter what he does,
If all available moves.
if there is a move where the outcome is that X wins, then X will win. So if there is a move, So if X has a move where the outcome will be that he wins. So that leads, the move leads to a position, and in that position he will win. In that case he wins. If for all, no matter what he does, the outcome is that the other one wins, then the other one wins. And otherwise it's a draw. And then, I mean, this is probably all not very ideal because now I have to duplicate code. I mean, this I can now because that's so now it's O turns. So if there is a move that he can move to where he will win, then he will win because he can pick this move. If on the other hand, no matter what he does, the other one can enforce a win, then he loses. And so I think this might be correct.
Line 150 as the equal signs instead of the type.
Thank you. What is it complaining about now?
Likely just a parenthesis.
Okay. I'm sure one could do this all much more elegantly. Anyway. Okay. I mean, would be nice if the result was draw.
I think I'm not sure if you can. No, tic-tac-toe can always be draw, right? Or can always be
Yes.
the first one. No, can always be drawn. Okay, so something from.
Huh. Why? It's Wood's turn. I don't understand it.
There might be a case that we're not taking into account.
Right. Or maybe we now just found that X always has a winning strategy. I mean, one could, of course, I mean, I suppose one should somehow debug it now, but I mean, we are running out of time. But I mean, for example, And this is of course not a legal.
Yeah. And we're not checking for legality yet.
Right. So in this case,
Okay.
and this is correct. But on if it's O, okay, that's like promising. And now, I mean, if for example, there's a nothing, but it's O's turn, yeah, then O wins. That's good because he can move there.
Hmm.
And if it's X turns, okay, it says that O also wins. But I mean, this is
Yeah, but the thing is, like, you're starting with 2 O's, so that's not a realistic setup.
yeah, I know.
Maybe if you can add just in the other list an X somewhere, just X like somewhere else. Yeah, there. Just so it's like a legal scenario.
Yeah.
Now should be maybe a draw or okay.
Strange. I mean, of course, there can be a mistake somewhere here, but I think this is correct. And ideally, of course, one would not only, I mean, what one would like approved, like in this case, one would like to see that, I mean, which move makes me win.
Right. Yeah, I would like to get like the whole history of the moves.
Yeah. So yeah, I'm sorry. I'm afraid we are out of time now, and I think this is all inelegant anyway. And I'm pretty sure one can use the fact that this rose has a comonad instance to somehow make that easier. That you basically don't have to do this recursion. That is happening automatically from the comonad instance. But
Jason must be so happy that we are leaving him homework.
Yeah. Fun.
Right. So yeah, probably. I mean, it's a pity that's the last lecture, so we can't. Otherwise, I would like try to think about how to do that properly. I mean, it must be a silly mistake somewhere. And somehow it shouldn't be so. I mean, it's like too fast, I think. I mean, tic-tac-toe is simple, but not that simple. I think it shouldn't be able to answer so quickly. And the result should be draw.
Yeah, I think we might be missing some case somewhere.
Yes. Anyway, so I think we must stop here. Does anybody else have any questions?
Yeah, so we are fine. Yeah.
Yeah, then we should. So yeah, then if there's nothing else that anybody has to add, so next week we want to share feedback form with you so that you maybe can fill in, so that we see some. I mean, maybe get some ideas for future courses. But definitely, I thank you all for your attention and that you like stuck with us for how long was it now? 3 months or forgot? August, September, October, something like that.
Yeah.
So yes.
Yeah.
And yeah, thank you for all the time you spent with that, and I hope that you learned a lot. and that some of you will use that to, I mean, maybe like someday work as a Haskell developer or do some nice projects on Cardano, and then hopefully meet some of you again, maybe on some Cardano meetup or summit. And of course, you can always feel free to contact us. I think the Discord is, I mean, it's not going anywhere, right? So you can still ask questions there. So yeah, I hope you enjoyed the course and learned something, and yeah, wish you all the best. So thank you very much.
Thank you.
Thank you so much. Thank you so much.
Thank you,
Thank you.
everyone.
Thank you. And we will talk soon, Anderson.
Yes,
Right?
we'll,
Yes.
yes, we'll
Yeah.
talk soon.
Okay, then. Also, thank you, Robertino and Karina, for all your help. And yes,
Okay.
thank you very much, everyone.
Bye,
Thank you.
everyone. Thank
Bye,
you.
Bye.
everyone.
Thank you. Bye.
Thank you.
Thank
Bye.
you.
Thank you. Bye.